Welcome to the second part of this revision, and today let's talk about periodicity. I do not intend to take time. I'll just go straight to those shortcuts that you need to know, and in the next 15-20 minutes we're done. Let's start with periodicity. So they can ask you to define periodicity. So periodicity is the variation in periodic properties. Periodic properties across the period and down the group. So if they ask you to define periodicity, is actually the variation, how these properties vary across the period and down the group. Next, they can ask you to state the law of the periodic law. This periodic law. So the periodic law states that the physical and chemical properties of elements on the periodic table are periodic functions of their atomic number. Let's take that again. The periodic law states that the physical and chemical properties of elements on the periodic table are periodic functions of the atomic number. So the summary of that is that elements are arranged on the periodic table in order of increasing atomic number. So this is a question they can ask you. According to the periodic law, elements are arranged in order of dash: A, mass number, atomic mass, molecular mass, molar number, different things. The answer is atomic number. While periodicity is how properties vary across the period and down the group. Now, so when we talk about period and group, the first thing I will be giving you a mnemonics, which is VGC and pH. What is VGC and pH? VGC means groups are vertical. Groups are vertical in chemistry. That's VGC. Groups are vertical, periods are horizontal. pH is Port Harcourt, right? But in chemistry, it means periods are horizontal. VGC is a location in Lagos, Victoria Garden City. But in chemistry, it is groups are vertical in chemistry. So groups vertical, this is vertical. When you stand and you raise your two hands up, this is letter V. So this is vertical, but when you drop it like this, this is horizontal, right? So horizontal, this is horizontal, and that is the arrangement of elements in periods. So periods are horizontal, groups are vertical. Take note of that. So they can ask you to define group. What is a group? Groups are a vertical arrangement. Vertical arrangement. Vertical arrangement of elements on the periodic table. Now they can ask you what can you say about groups? Members of the same group, they have same number of valence electrons. And what's the meaning of valence electrons? They have same number of electrons in the outermost shell. So electrons in the outermost shell. That's the meaning of valence electron. Now let's talk about period. Period refers to the horizontal arrangement of elements on the periodic table. Now that's not all. Before we come back here, members of the same group, what do they have in common? They have the same number of electrons in their outermost shell. Number two, they have similar chemical properties, and because of that, they take part in similar chemical reactions. So example of elements in the same group, all right, e.g., if you look at group 1, you have sodium is there, you have potassium is there. Sodium and potassium, they have one electron in the outermost shell, therefore they are in group 1. If you look at calcium and magnesium, they are in group 2. All right, and like that. Now let's come to period. This is the horizontal arrangement of elements on the periodic table. Then what do members of the same period have in common? They have same number of electron shells. Same number of electron shells. They have same number of electron shells. So if you look at period 1, they all have one shell. Look at period 2, they have the same shell. Period 3, same shell. And if you look at another thing is their atomic number increases across the period. The atomic number increases across the period. Then their valence number of electrons, the number of electrons in the outermost shell as you go across the period, it increases. So their valence electron increases across the period. So these are just introduction. Now let's now talk about those periodic properties and how they vary. I told you I'll give you a shortcut to do that. So those properties, number 1, we have atomic radius, ionic radius, electronegativity, ionization energy or ionization potential. We have electron affinity. We have boiling and melting point. Then we have thermal and electrical conductivity. And of course we have electropositivity. Positivity. So I will quickly give you the shortcut. So they can ask you to write on any of these, meaning you are expected to define what this is and then tell us how they vary across the period and down the group. So I'll give you a shortcut you will use to know this now, and we'll be done with that. Let's talk about these properties using the short formula that we have. So the first one is EIA. What is EIA? EIA means electronegativity, ionization energy or ionization potential, then electron affinity, GA for affinity, electron affinity. You see all these three, they have the same periodicity on the periodic table. They have the same periodicity. So what do I mean by same periodicity? They all increase across the period and decrease down the group. They increase across the period and decrease down the group. So let's define each one. Electronegativity is the readiness of an element to become negatively charged. Okay. Is it by losing electron or gaining electrons? It is not by losing. Givers are positive. So when you give, you lose it out. Receiver, beggars. So let's use beggars. Beggars means you want to accept. Beggars are negative. So borrowers are negative. Givers are positive. So electronegativity is the readiness to become negative by begging for electron, by borrowing electron. Are you getting the gist now? So elements that are highly electronegative like chlorine, fluorine, Chlorine is number 17. If I write the configuration 287, right? Chlorine needs 1 electron to attain stability, to have 8 electrons in the outermost shell. So it will borrow 1 electron. So when it borrows 1 electron, it will now become 288. So this ability, readiness to borrow 1 electron now becomes Cl minus. All right. This readiness to borrow 1 electron is what you call electronegativity, the readiness of an element to become negatively charged by accepting electrons. So let's define it. Electronegativity. Electronegativity is the readiness of an element. It is the readiness of an element to become negatively charged by borrowing electrons. Now once you have defined, the next thing you now write is the periodicity. I told you they all increase across the period, so it increases across the period and decrease down the group. That is that, electronegativity. The second one is ionization energy. Ionization energy. What's ionization energy? This is the energy that is required to remove an electron from the outermost shell of an element in its gaseous state. Is the energy required to remove an electron from the outermost shell of an element in its gaseous state. And this ionization energy, it increases across the period. So now chlorine is in group 7, sodium is in group 1, sodium is 281. If I want to remove an electron from this outermost shell here, you know, this guy wants to, all of them want to have 8 electrons in the outermost shell. So this guy, it will not cost him anything to give away 1 and have 8. When he gives away 1, it has 8. Very easy. So when I want to remove an electron from the outermost shell of sodium, it will be very easy. That means the energy is low. But if I have chlorine, this guy has 7 here, needs just 1 to attain stability. So if I try to remove any electron from here, I need very strong energy to pull out an electron here. Because the one you want to come and borrow from here, if you don't hold that one very well, this guy will kidnap it from you. Because these guys, group 7 elements, they are halogens, they are ferocious kidnappers. Sorry, I'm using that word, but they are ferocious and they collect electrons. So you call them radicals. They are very reactive. Okay, so that is why. Now I've done a video on periodicity. Basically, you can check up the video to see the breakdown. I drew the diagram of the periodic table and I explained how they increase or decrease. But to make this class faster for you, just use electronegativity. Once you are able to define it, then you are able to tell us this is increased. All these 3 are increasing across the period. So number 3 is your electron affinity. What's electron affinity? Affinity simply means love. So electron affinity means love of electron. So it's the love of electron, but you can also define it as the energy that is lost when an element gains electron. Energy that is lost, okay, when an element gains electron in its gaseous state. Energy lost, that's electron affinity. Energy lost when an element gains electron. Now this property also, it increases across the period and decreases down the group. I said for electron affinity, it increases across the period and decreases down the group. So those first three, EIA, they all increase across the period and decrease down the group. Now the next three I'll be giving you also, they have similar periodicity, and that is they decrease across the period and increase down the group. And those are, so the acronym I'll give you is your P A or PR. Let's do PR. PR. What is PR? PR means P for electropositivity. So the next one, number 4, positive, electropositivity. So PR means electro. P is for positivity, R is for radius, anything that has radius, whether it's atomic radius, all right, or ionic radius. The fact that it has radius, it is increasing across, so increasing down the group, decreasing across the period. So electropositivity is the opposite of electronegativity. It's the readiness of an element to become positively charged by losing electron. So readiness of an element to become positively charged by losing or giving out or donating electrons. Now, what happens with this property? It decreases across the period. Decreases across the period and increase down the group. Increases down the group. That is electropositivity. We have discussed electropositivity. The next one, number 5, atomic radius. Number 6, ionic radius. So both, they increase down the group, and decrease across the period. Both. Okay? So how do we explain it? Look at this. You remember elements in the same period, they have the same number of shells. So elements in period 1, we have just one shell. Elements in period 4, we have 1, 2, 3, 4. 4 shells. And what is radius in mathematics? Radius is the distance from the center of a circle to any part of the circumference. That's radius. So an element that has only one shell, okay? An element that has only one shell like this. Look at the radius. Compare the size to an element that has 1, 2, 3, 4. Who has a longer radius? The element with the more number of shells. So that means as you are coming down the group from one period to the second period to the next period on the same group, their number of shells increases, and because of that, their atomic radius and ionic radius increases. So the difference between atomic and ionic is atom and ion. Atom is the neutral atom without any charge, all right, which is this. The difference between atom, this is an atom, Cl. My chlorine is an atom, while Cl minus is an ion. So here I'll be talking of ionic radius, here I'll be talking about atomic radius. How that is clear. Now, we have discussed periodicity. Let's quickly talk about a shortcut formula that you can use to calculate your solubility, and then we continue. Solubility. This question says calculate the solubility of 58.5 grams of sodium chloride present in 250 centimeter cube solution at 50 degrees Celsius in mole per dm cube. So you have to calculate the solubility in mole per dm cube of sodium chloride, okay, in 58.5 grams. So what are the parameters given? The mass given is 58.5 grams. Then the volume is 250 cm cube. They were given temperature, but note, you don't use temperature in calculation of your solubility. Many students will now start converting this to Kelvin and wasting time doing irrelevant things. You don't need that. Sorry, I'm having to check my this. Now, you don't even need the temperature. All you need, once you have done your calculation, you now go back and say the solubility of sodium chloride at this temperature, at 50 degrees Celsius, is that, or is this. You state it there. So you are not using this for your calculation at all. So the formula you are going to use for solubility, the formula is you are combining equation 2 and 1 from your stoichiometry mole concept. The first one says number of mole equals to mass over molar mass, and the second one says number of mole equals to molar concentration times volume in dm cube. Now note, this solubility they are asking you to find is the same thing as molar concentration. That's why they said the solubility in mole per dm cube. So it's the same thing as molar concentration. So here, my first equation is number of mole equals mass over molar mass. My second equation is N equals CV. So if N is this and N is this, I can as well say if N is this and N is this, therefore CV equals to M over MM. Then I will make my C the subject of formula, and that will be my solubility. So I'll cross multiply. I will have CV times MM equals to M. Divide both sides by V times MM. Divide both sides by V times MM. This will cancel this. So my solubility C, which is molar concentration, is equals to mass over volume. You remember in this formula, the volume is in dm cube. So volume in dm cube, are you there? Times molar mass. This is the formula, the first formula you can use to calculate your solubility. Solubility C is mass over volume times molar mass. Mass in grams times volume in dm cube. So that can be rewritten as so that is mass divided by volume times molar mass. So I can rewrite that as solubility, okay, is equals to mass over molar mass, mass over molar mass times 1 over V in dm cube. 1 over V in dm cube. So this is equation 1. Or if I want to derive the second formula, I will still come back here. Since my N equals CV and I need my C, my C is what? N over V. N over V means N divided by V. And my N is number of mole, and that number of mole is mass over molar mass. So I can as well say my solubility is mass over molar mass divided by volume in dm cube. So my solubility is equal to mass over molar mass divided by V in dm cube. By V in dm cube. Divide with this and this are the same. Now this division, if I change this to multiplication, my solubility will be what? equals to mass over molar mass times 1 over V in dmq. So that's how they got this. V divided by 1000. Are we there? But because I want to now change this division to times, my solubility will now be mass over molar mass times 1000 over V in centimeter cube. Why did I write this? Because when I divide my V in cm cube by 1000, it gives me dmq. It gives me V in dmq. So this V in cm cube divided by 1000 gives me V in dmq. So, but because I'm now changing this division to times, my 1000 goes up, my cm cube comes down. So this is the second formula you can use. Either of this or this, you get the same answer. Solubility is mass over. So now to calculate this question, let's calculate the molar mass of sodium chloride. So sodium chloride is what? Sodium is 23, chlorine is 35.5. If you add it, you have 58.5. That's the molar mass. So the solubility is going to be what? What's the mass? 58.5 divided by molar mass is also 58.5 times 1000 divided by our volume is in cm cube 250. Okay, this cancels this. 250 here, the answer is 4 mole per dm cube. Woo! That's the answer. 4 moles per dm cube. That is the solubility of this substance. So this question says, what volume of 0.20 mole per dm cube solution of sodium hydroxide would yield 5 grams of sodium hydroxide on evaporation to dryness? So this is a solubility question. They evaporated this solution, meaning they removed the water, separated the solid and the water, the solute and the solvent. Now they are now saying the amount of the solute that dissolved in the solvent and gave us this concentration. What is the amount of volume of the solvent? That's what they're asking. So it's a solubility question. So all you need to do is write out the parameters. Concentration is 0.2 mole per dm cube. The mass of the solute is 5 grams. The molar mass of sodium hydroxide is 40 grams per mole. And we are looking for the volume. So let's use this formula. Your C or your S solubility, whichever name you are giving to it, equals to mass over molar mass times 1000 over volume in cm cube. If we slot in our values, our C is going to be the mass is 5, molar mass is 40 times 1000 divided by V, which is what we are looking for. And solubility is 0.2. So here is 0.2. So if we cross multiply, we'll have 0.2 times 40V equals to 5000. So divide both sides by 0.2 times 40. 0.2 times 40. This cancels this. So the volume will be 5000 divided by 0. So if I move this, it will cancel this. So 2 times 4 is 8. So 5000 divided by 8 is going to give me 625 centimeter cube. 8 in 50 is 6. That's 48. 49, 50 in 20 is 2. 16 remainder 4 in 40 is 5. So the answer is 625. Do we have that in the option? That is the answer to the question. So I hope that is clear. So I don't want this video to be too long. If you have not seen the first part, check the description to this video. I have dropped the link to the first part of this revision where I treated stoichiometry mole concept. All right, I dealt with that and I dealt with other topics in that first one. So in this second part, I've dealt with this, and then there will be a final one where I will also talk on other topics. I wish you success in your exams. Bye for now.